Welcome everyone. Thank you for joining us for today's webinar. Myself Dimple Khambati and I am the head of Biomedical Engineering Department, Parul Institute of Technology, Parul University. So today we are presenting over here a scope of research and implementation of new methodologies and modalities in image processing techniques, and which is presented by Ms. Priya Kansagra. She is an alumni of our biomedical engineering department. She has joined biomedical engineering, BTech biomedical engineering in 2015, and she has completed BTech biomedical engineering in 2019. And right now she is working as a biomedical engineer at Tricolor Hospital, Vadodara. Okay, so she will explain today's topic in very deep. So without taking too much time, I will hand over today's session to Ms. Priya. Yes, Priya, you can start your presentation.
Yeah, sure. Welcome to everyone present here. Today we will be discussing about the topic, a scope of research and implementation of new modalities in image processing and techniques. First of all, you should be aware about what is it, means the topic is in what. Like, we have an image processing, okay. Image processing in a medical field and an other field is totally different concept. First of all, the image. What is an image? Image is a thing and an object that could be a physical, that could be transferred to a binary, digital and analog process. That can be transferred to a process to have an object, right? And we would be discussing about whole methodology of image processing, techniques, new modalities in the healthcare department, all of that stuff. Okay, let's start. So first of all, I would like to explain what is an image processing. First of all, the basics should be clear, right? So what is an image processing? Image processing is any form of a signal processing for which you have an input in an image to have like a photograph, video or an object to have proper image like an object type. Okay, and there are like an post imaging also, analyzing operators to have an image processing, and there is a functions for the image processing. Like we have a certain segments, we have an overlapping concept to perform the image processing function. Okay. Next, what is an image processing? Means in a real world. First of all, we have an images like CT scan, MRI. Then we have an original image. Okay, let's take this is an image of an chest. It's an original image what we get from an X-ray. So this is an image while we get an X-ray. We need to process it. This is an all internal function. It is being processed by the system. What we are doing is just an outlook of a machine, but the internal this all process is ongoing. So we get this original image, then we just make it in a processing program. There are certain programs, apps from which we can do a process to have an image processing. Once we do a program through a certain software like MATLAB, R program, then LabVIEW, these are the software which help us to transfer the original image to an image processing image. So you can see that the original image is like a dark shade, while we passes means program is passed and then we get an original image. That in that we can see is the real image of a chest. From that we can visualize what is the exact part of our body in image processing section. Okay. Next, we have the goals of medical image analysis techniques. First of all, we should be knowing what are the goals while we are focusing on a particular topic. there are certain points we should take care of it, like quantification, computer aided diagnosis, and evaluation and validation techniques. Okay, so what we do in that, measuring the features on medical images, like an before only mentioned, like an MRI, CT scan, X-ray, radiologist. Okay, obtain a measurement from medical image. This is that quantification. Now we have computer aided diagnosis. Given measurements and features, make a diagnosis help radiologists on their diagnosis procedure for accuracy and efficiency. Like CAT is an important feature, an important diagnosis to do a measurement features of a certain images, while the radiologist giving about the disease and the profile. Means like what are they having an problem in their reports, it can be described from our images, like an this image processing images is being proceed in the X-ray. Okay, and valuation validation techniques are the accuracy thing which we get, it means a proper way to describe an image. Okay, now what is the purpose of image processing? We have certain purpose to have this. Okay, visualization, image sharpening and restoration, image retrieval, measurement of pattern, image recognition. These are the certain purpose of image processing. We should be like observe the object that are not visible. The object which are not visible, that should be done by image processing section. Okay, and the image sharpening and restoration, it helps to create a better image. Like if you have an image that is not in clear, so you can be doing it by an image sharpening and restoration. Now we have an image retrieval to have a shape for the image of interest. Measurement of pattern, measure the various object in an image. Means an image is just by looking, but it have a lot of things, lot of measurements, lot of minor sharpening, minor pixels to measure. Due to that all things we get an image. Okay, image recognition, distinguish the object in an image. We are having a lot of image, we are having a lot of object, but we are discussing about the recognition. We should be knowing how to recognize which object is there. By pixel, by segments, by patterns, we can recognize it. Now the main thing is about the whole process, how to get an end. Okay, so how to acquire an image? First of all, the image collection should be done. Image collection is like you can get it the images like from imaging center, your hospital, your Google. There are a lot of things, lot of departments from which you can get an image. Okay, image in the sense I'm talking about here an medical image, like an X-ray image, MRI image, CT scan image, PET image. These are the different images we can collect and we can proceed further. Like then the next step is pre-processing. In that what we do? Then we have image segmentation. Then we have feature extraction and the tumor detection. This is an example I am giving you about the brain tumor detection. Okay. First of all, I would like to explain the brain tumor. Okay. One, if the person having a brain tumor, we need to collect an image. Suppose you are taking an image of an MRI machine. Okay, so you would be having an image, that is image collection process. Now pre-processing. you need to have a program to pre-process. Okay, in that you need to have a proper way to proceed further. Then you need have a image segmentation. In that the whole image would be segmented in multiple. Then the feature extraction, there you would be having an all color pixel measurements. This all features would be included in that. And then you would be getting a final tumor image which would be represent to the patient. As I told you, pre-processing. Pre-processing is an improvement of an image data, that is, suppresses the unwilling distortion or enhance some image features important for the further processing. Like in that, we need to enhance the image. We need to enhance the image like this. If I am having an original image of brain tumor, that would I have enhanced it and it is turned into black and white. So now I am able to detect it, like, okay, where exactly in which portion the tumor is. Okay, so from the pre-processing technique, step, we can visualize that it is in a black and white portion. In a white portion, we are having some type of a jerk, and we have a tumor there available there. Okay. Now we have image segmentation. Image segmentation is a process of partition of a digital image into multiple segments, like an set of pixels or like an pixels, that all are known as superpixels. A goal of my segmentation is to simplify and change the representation of an image into something that is more meaningful or easier to analyze. Okay, so like as I mentioned, we need a proper segments to visualize in which part the tumor is. Okay, so we just have a process to multiply the segments in a small areas. If it would be multiply in a small areas, then we would be knowing the exact location, exact area to detect it, and we can rectify that problem. Okay, so this image segmentation is very useful for the radiologist, ultrasound, everybody. And even this segmentation help to know us about the pixels, what type of pixels it is. Okay, and it help to help to analyze our image very easily. Okay, as we have like original image of a brain tumor and segmented image. As you can see, in original image you can see whole tumor, and in segmented, this is an area where we have then multiple segments, and it's like an almost in boundary area, so that we can detect it. Okay, this is the area, this is the location where we can have our tumor. And previous it was like just in black and white image, there we were not able to detect where is the tumor located, but in this we are bit clear about where it is exactly. Now we have feature extraction. It is an important factor to study as it helps to differentiate between malignant tumor and benign tumor. Age is essential features required, and since the inherent nature of the brain tissues is such, it not easy to find the sharp boundaries of the tumor. This nature and pixel arrangement of the age is considered for detection of brain tumor. As I explained you, feature extraction is then one of the most important part, because the pre-processing and image segmentation are not that much the part of it, as feature extraction cover up whole process. It helps to detect the two tumors. It also helps us to analyze the boundaries of the image. It also helps us to age the sharp boundaries. It also helps us to where the tumor is, where the our whole area is, where what type of the tumor is, what size of the tumor is, what is the nature, what is the pixel, what is the age, and how we can detect it. This feature extraction is one of the most important factor in our image processing steps. As you can see, now I have all four images. Like, first of all, we have an original image, then I have a diluted image, then I have an eroded image, and then I have a morphological grid. These are the four features in a feature extraction. First of all, when we have proceed our program, we are having a diluted image. Then we have eroded image, and then we have morphological grid. From this all four, we get total final image like an original image. Okay, this is being done through our image processing steps. This is a case study I have been done. Like, it was like of small tumor, medium tumor, and large tumor. As you can see in a first subject, there is a very minor tumor in the brain. Okay, this can be detected through an image processing. First, we had a program on our through a MATLAB. We just did a program on through a MATLAB about the image processing. First, we got an image pre-processing step. Then we had an image segmentation step, and then we had a feature extraction step. As you can see, the yellow mark is totally like feature extraction step 1 image. From that point of view, we can detect it is in a which part, and it is already boundary, so we can get it clear that this is the tumor. Like, in the subjective, we have an image of a brain only, and it is in the upper part. Okay, so this is then another thing. Like, it can be in any location. It's our image processing techniques and steps. We need to find it out where it is from an image. This is like a black and white image processing technique, and then we get a detected tumor. As it is bounded, it would be like in any shape, but the thing is, we get a boundary exactly what is the tumor is. This is all done through an program of MATLAB, what I have preferred. You can be doing your own, means you can use like SK line, then number py. There are the different software also, R language. These are the different software you can be using to detect this boundaries, location, and thickness of the tumor. Now, in the third subject, I have a large giant tumor. Okay, that is also being detected. It's like an performed pre-process step, the image segmentation, and then we got a final image. So, how this works? First of all, we have a problem domain. Then we have an image acquisition. Image acquisition is an image collection. Then we enhance the image. Okay, as to enhance it means to make the image very clear, to make further restoration process. What is restoration? If your picture isn't dull, we through an restoration we make it like a clear true image. From morphological process, we are supposed to do all the whatever the dead pixels are there, it's being removed. Noise cancellation is being done in morphological process. Now we have a segmentation. Segmentation is like an image is converted into multiple segments, and it is then being proceed to an object recognition. In segmentation, it's like an already multiple segments, so it would be very easy to get an object recognition. Once we get an object recognition, we will be having a description about the object, what it is exactly, how it looks, because there are many images we are not able to detect how it is by looking it. Okay, so this is the process, this is the way, this is the flow by which we can get a clear true image. Especially in a medical, all these image like MRI, CT scan, PET, all these images are like very complicated. By looking, we can't say where the tumor is, where the problem is. So we need this certain type of process, certain type of flow to detect it. So where representation and description. From object recognition, we get a proper description representative. Then after that, we have an image compression. What is image compression? Image compression is in like comprises the image in a proper size and a proper pixel. And then we have a color image processing. In a color image processing, we get a colored image within a proper measurement, proper segments, all that we get in a final image. Now we have 6 process techniques of imaging. Like first we have an image restoration, then we have an linear filtering, then we have independent component analysis, then we have pixelation, then we have template matching, image generation techniques. These are the top 6 image processing techniques used by everyone in the field of medical, non-medical. First of all, image restoration. Now, first of all, as we know that our grandparents has a lot of pictures, right? So, but they are not that clear as we are having right now. We have latest technology, but earlier there were no that type of technology that can have a proper image. As you can see, this image is totally like destroyed. If we want to just restore it, we have a process like an image restoration. Okay, in that what we have, we just destroyed it, the whole image, to perform it and have a true image. If the first picture is totally a destroyed image, okay, then it is totally degraded. Now we want a proper image to have it. Okay, so from image restoration process, we can get a proper true image, real image. Okay, so first of all, before distortion, it is called as a true, before degradation, it is called a true image. After this degradation, it is called observed image. And degradation filter is being used, that is we get a true image. And it is being used not only in any picture, it is used in all the pictures of medical, non-medical. Now we have linear filtering. In linear filtering, we have 3 objects. Okay. First of all, what is linear filtering? It's a value of an output pixel and is linear combined with the another neighboring pixel. As we can see, original image is different than the last image. Thus, the second image is sharp kernel image. In that, we have just performed all the programs and it's in like pixel is visible, all the lines is visible, and in a third, you would be like totally different, having a color change, having a sharp boundaries. This is what, and we are having a linear filtering. There is in a methodology also, in a math section, we are having a program on this. From that we get in this all images. Like you need to have an input image, you need to have a filter image, and then we get an output image. This is the process of linear filtering, to sharpening the edge and sharpening the border of our image. Now we have interdependent component analysis. This is what something like we are a mixed signal image and then it is transferred to a true sources. As you can see, first we have a mixed signal like an jerk like, and then we got a waveform and an echo type form. This being detected from the outsource, and then it is converted through an independent component analysis. Okay, then we get a proper waveform, proper flow to detect the things. Now we have an second image that is like in a sound noise. Okay, so that is converted in a waveform as an upside zigzag term. This is the independent component analysis. It is also known as short ICA. A technique is used to just convert multiple variant into underlying components, and the extraction of desired components from a mixture of the components. It is an extraction of many multiple variants to a single thread like component. Now we have pixelation. What is pixelation? First of all, we should be very clear what is pixel. It's a minute area of illumination in a display. As you can see in the next picture, there is a lot of pixels, lot of squares, small. That is known as pixel. And pixelation is a occur resizing of an image from individual pixel to a stretched pixel. As you can see, the first picture is like a proper picture, and the second one is like it's a stretched one. We are having a stretched pixels, so that is a pixelation. Now we have template matching. Template matching is something like a comic book. It's like searching and finding the location of template to a larger image. If you have a larger image and you want to find out a smaller in that, you can use a template matching. Template matching, you can see this beach photo, and you can find it out. That is in a red box. Okay, they are the template matching. We can just zoom in and we can find it out a template matching. In that, we can get the exact portion of it, and we can detect what it is there. Template matching is a simple approach to an object, object to have a look to a deeper and brief zoom image. Now we have image generation techniques. What is image generation techniques? It is also one of the technique of our modalities and image processing. It is used everywhere to just have a generative adversarial network. We can train a deep image model to from a normal image to generate same type of the image data. This is a technique. From an your generation image, we can have a same type of image from this technique. Okay, it can be like to generate, and there are two forms of it: generator and discriminator. Okay, from generator, it's we get a fake image, and from the discriminator, we try to classify the fake and real image. So discriminator is in such a filter, we get two description like fake and real. From that two, we can discriminate which is fake and which is a real one. Okay. Now we have major modalities. There are many modalities, but the few are being mentioned here. The first one is projection X-ray. The next is X-ray commutative tomography, that is CT. And we have magnetic resonance imaging, then ultrasound, nuclear medicine, magnetic resonance angiography, and fundus image. These are the major modalities being performed in image processing field. And due to this only, we are having an image processing technique. If this modalities would not be discovered, we would be not able to use our image processing section. First of all, we have an X-ray. X-ray is a part of a radiology department and is a machine which was introduced in November 8, 1895, and it have features like motor, vacuum, then a filter, the electron beam, cathode, and tungsten anode. Okay, so how it works? First of all, the rays just pass through an anode. It just reflects on then that motor and the vacuum and tungsten diode. It reflects to an outside, that's in a patient, that is an X-ray beam. It's totally directed on an X-ray beam, and then it is onto the film. That film is the way to get an image. This is the process of an X-ray, how to get an image from the X-ray. And films provide a measure of ray attenuation in tissues. Okay, the film and this ray are just in a way how we will be getting an image of an internal parts of the body. Okay, these are the, like, if once the ray falls on an image on an object, it is directed to a film. On a film, the impression is being interpreted. That impression is being an image for our tissue. It would be like chest, it would be like a hand, leg, it would be any image. It would be like such. The samples of an X-ray slice. Once then X-ray is done, and the X-ray film shows like this. The first image we are getting it is of hand. You can see these are the hard tissue. We are getting the image. Then we have a tooth video, tooth photo, and then we have a chest video. Those are the three X-ray slides. I have been getting it from my known colleague. Through there, we are doing an X-ray, and you can see. You can clearly see how many bones, how many, where it is a crack, you can find it out. This is a technique of image processing through which we can detect the problems, we detect the cracks. Now we have CT. CT was also introduced in November 8, 1895, and it also have different features from the X-ray. Well, this CT helps to detect us in hard tissues like in bone, like all the thick things on our body. Okay, provide a 3D anatomical information. As you can see, CT scan is a vast and a long machine, and it have certain slices. It have certain parameters, and CT also have a slice of from 24 to 124 images, and it's have mostly every department of hospitals are having a different slice machine. The more this slice accurate, the more the accurate image you will be getting. Okay, and it is like having a less excessive radiation. The body is not get harmed, and we have not good for all soft tissues. Means there are certain tissues get harmed from it. So image formation, the object is viewed from a number of different angles, and then cross-sectional image of it can be. Like we have a 3D reconstruction in CT. As I mentioned, it have multiple slicing. If multiple slicing would be done, then we would be having a spiral volume. Spiral volume create a good image of an object. Like you can see, this is an image of an spinal cord, heart, and our front digestive system. Okay, so if we are having an image of an spinal cord, it would be very accurate through this CT scan. Why? It is like a hard bone. Hard bone are very familiar with a CT scan machine. Okay, so we are getting it with the proper image, proper area to detect it. This is an CT scan slice. This is totally different than X-ray. We are getting it in a whole area to detect where the problem is, what are the internal functional is from the CT scan slice. The first picture is normal. The second picture we have transferred, segmented it, and the third one is we are getting a proper image where we can see what is the detected area. Now we have magnetic imaging resonance, MRI. Okay, so in this MRI we have an image formation. The hydrogen protons under a strong magnetic field spins in a phase with one another and align with the field. Relaxed proton induce and measurable radio signals. Okay, so in that what happens, like hydrogen protons just spin under the magnetic field, it creates one phase and then it's aligned with that field to another. Now relaxed protons induce in a measurable radio signals. It is, we can measure the radio signals, right? So these protons are relaxed to induce in that signals. So we are very familiar with the protons to get under the magnetic fields spin. Okay, so once it get aligned, then we are having a whole process, and there are certain plus and minus in MRI. So it's like main modality for image guided surgery. Okay, while this process is done, this machine is being used when someone is having a surgery. It is being guided by a doctor to have a surgery or having some problem in his or her head or some other parts. Superb ability to discriminate between subtle differentiation in tissue characteristics. Okay, we even able to discriminate the characteristics in the tissue. While this is an advance than the CT and X-ray. There we were not able to describe the characteristic, but here we are able to describe the tissue characteristics, and it is very safe and less accurate for the bone scanning. It is mostly used for soft tissues, not being used for the hard tissues. As we can see, a sample of MRI. The first picture is then being original, then we get that image segmented, and then we get a final image. And ultrasound. Ultrasound is also one of the modalities being used as an proper way to treat the people. Like ultrasound energy is fragmented into a patient from a transducer placed on a skin and backscattered in an echo signal and is recorded by the same transducer. Okay, how it works? Ultrasound energy is like we have a transducer in a machine. Ultrasound are different type of machine and a different type of transducer we have in it, and there are some parameters also in a transducer machine, like we have an polar, bipolar transducer. There are different transducer also for different treatments. Here we are talking about a general transducer it can detect and scan and back scattered echo signals. Like what transducer do? It just take and back scatter signals from a scan, and it is being interpreted in a machine, and then we get a total visual image on our screen. It is a totally non-invasive process. It is safe and clean. It is inexpensive. It is noisy, and a gas-filled and bony structure cannot be imaged because they absorb the ultrasound wave. As we were doing in bone structures imaging in a CT, X-ray and MRI, but here in ultrasound we are not it's a disadvantage of ultrasound to have a bone structure we can't able to do. But there are other things like an echo, ultrasound processes we can do through an ultrasound machine. As you can see, this is a sample of an ultrasound how we get. There the machine and the patient and the doctor, it's like an what we can say, a computer panel, ultrasound gel is being applied on the transducer to have a clear image, and that would be like skin would be transferring the echo signals to a transducer, and transducer would be programming it in the our computer panel, and then we will be able to see this picture. Now we have a PET. Now what is PET? Positron Emission tomography. It is also a part of modalities. It's a like detection of radiation from emission of positron. Like this is an also like same similar to a CT scan, but this is a different concept. We are able to detect the radiation that is emitted by the positron from the machine. Okay, like as you can see in image, the person head is totally in that round shape. From there we can have signals and being passed from the positron from the inside. Valuable technique for some disease and disorders. Like there are certain diseases and there are some diseases being means used by these techniques. From these techniques we can be able to detect that disorders. The amount of radiation is small and invasive. The radiation being affected to our body is very less, and it is an invasive process. Inject a radioactive material. In that we need to inject in dye in the to perform this whole process. In this also it's whole image processing techniques and the methods is being used to perform and to evaluate on a person disease. As you can see, these are the samples of PET. In this we get a color image. We can be able to detect where the on which area the small soft tissues are available, where the tumor is available, where it is located. You can see it. First image is being a PET image, then it is being processed, and then we get a final image. So from that our doctors and our all experts are able to know the area of the tumor and the thickness of the tumor. Now we have a magnetic resonance angiography. This is also one of the latest technique being used by the doctors and in hospitals. Image formation, imaging the blood vessels, moving spine using the MRI scanner. We would be able to detect the blood vessel while it is having a moving spine. Okay, there are different type of angiography like phase contract angiography, contrast enhanced angiography, computer tomography angiography, then we have digital subtraction angiography and time of flight. These are the few of the angiography can are being performed on the patient to detect different areas and different vessels through a moving speed. You can see this is like DSA, like the our this digital suppression angiography. Then we have CT angiography, and they have TOF angiography. In that, all the three are have been performed in a different part of our body, and all these three are being like in blood vessels. Some are having tissue, some are having vein. This all are three are different on a different angiography process. Now we have a fundus photography. Fundus photography is a creation of photograph of an interior surface of an eye, including the retina, optic disc, and macula. This is we can say as fundography. Is a creation of a photography in internally surface of an eye that includes the retina, optic disc, and macula. Fundus photography is performed by fundus camera, which is basically consists of a specialized low-powered microscope with an attached camera and posture pole. Like you can see in an image, this is the machine. Like from this we can perform the fundus photography. This is a sample for fundus image. Like this can be performed for optometrists, ophthalmologists, and it is being trained by a medical professional for monitoring the procession of a disease, diagnosis of the disease. Okay, this is fundus photography is mainly used in eyes section, and it is not being performed by any random person. It is being performed and being guided by professionals. Now we have in a list of application like medical image compression, medical imaging denoising. We have image filtering, medical image retrieval. We have mammograph. We have tumor detection, medical fusion. These are the application used through and this all modalities. And at the end, I would like to conclude it that in whole entire session, the main and the most important part is an medical image processing system consists of 5 things. That is preprocessing, enlargement, enhancement, filtering, denoising, morphological operation, segmentation, and detection. As I mentioned, pre-processing is one of the most important feature of an image processing system, as it just give us a black and white image to enhance it in a proper way with proper segments. Enhancement is a feature which will be helping us to enhance our pre-processing image. After that, we would be filtering it. We would be just cancelling all the noise and would be getting a morphological process image. And morphological image would be having a boundaries, multiple segments, and all that would be converted into a segmentation. Segmentation, as I mentioned, it was like multiple segments of an image to detect any part of the image. Like take an example of a tumor. We had multiple segments of a tumor, and then we were able to detect the proper image. Thank you.
Thank you, Ms. Priya. So you have covered all of the topics like how can we process the image in various stress, right? And for the various medical images like X-ray, CT, MRI, ultrasound, and all that thing. So it's look like you have covered all of the things, right? So
Yeah.
there is no questions from the student side, right?
Okay.
So thank you so much for the valuable time.
Okay.
And yeah, great. Thank you everyone. We appreciate you being here. Okay, thank you for giving thanks to University Health as Parliamentary Alumni Action. Thanks again for time. Priya, now you can leave.
Yes.
Now you can leave. It's over.
Okay.
Stop recording. Thank you.
Welcome.